Welcome back to another episode. This is the second episode in a series where we're just talking about concepts related to engineering. In the previous episode, you can see here the summary. You can watch the other video talking about all these different concepts and how they relate. In the second episode, I want to focus a bit more on engineering, mechanical engineering, and how we can get things done. So, you can see on this second sheet, I'm going to talk a bit about energy, work, and force. And so, pause the video. When you think of the word energy, what do you think of? All right, so energy, we might think energetic, somebody who has a lot of energy, and you see that. We might think of food and how we consume food and drink in order to gain energy, in order to do things. And if we think about not having food, then we don't feel like doing anything, and so we need that. Energy, and when we think about food and all that our body digests and metabolizes, there's actual chemical, biological processes that allow us to be able to function. So hopefully you can have that concrete illustration there as we think more sort of mechanically. So I want to start from energy because this is really where we get useful work done. And I know the terms are sort of overlapping. All right, you want to get things done. So let's actually just list out types of energy. So we have mechanical, electrical, chemical. We also have things such as nuclear, thermal, and I think solar too, we could distinguish that. Within mechanical, you can have things like elastic and hydraulic and pneumatic. I do not have spell check as I write here. And okay, so you can pause there, think about these things. When we go between the different forms of energy, and of course you can sort of interchange. The technical term is a transducer. It goes from one form to the other. So you might have seen things like a Rube Goldberg machine, right? It takes some sort of ball and it goes through this obstacle course, and usually it's sort of one of these three forms. I guess we also have gravitational. The physics teachers out there, they can correct me. But of course, the Earth's gravity, that is a type of energy. Okay, so if you look at electromechanical, this is actually one of the most important pieces, because if you think about the relationship, and actually, sorry, this really should be electrical magnetic. All right, so I'm just doing this for completion. These concepts, you would really have to spend a lot of time to really get into this, but again, I just want to understand this I want you to understand this at a qualitative level. So when we look at electromagnetic, and then with the relationship with mechanical, that's motors, okay? And motors are so important. All right, let's sort of walk through examples of these. So chemical, that's where we have batteries. So whether the car battery that starts up your car and then allows it to continue to running, and there's an alternator that takes the engine motion and keeps that battery charged up. If we think about thermal energy, we heat up food or keeping warm, things like solar. And I guess if we think about renewable energy, solar, wind, nuclear, those are all types of ways to get energy, and that of course is up for discussion and how best to use other resources. Gravitational, we talk about sort of the potential energy. So if you've got the ground here and you've got your block, if you raise it up some height, all right, some height here, again, I'm just sort of throwing formulas at here, but the potential energy is the weight of that block, the gravitational force, and the height. Anyways, elastic energy, so springs, all right, if you think about springs. And also materials. Materials, when they bend, let's draw a bent material. that is a type of elastic energy. So if you think about like a thin piece of metal, if you bend it back and you let it go, then it sort of vibrates back and forth. Again, if you really want to understand it, that's sort of a very more advanced topic, but basically the molecules in the piece of material, you're storing energy, and it's kind of like there's a spring-like behavior between molecules. Hydraulic, we think of some sort of fluid, some sort of liquid, so whether it's water or oil, and you'll see a lot of big machinery function on hydraulics. And then pneumatic, that's focused on air, and so because air is compressible, we can do work on air, which is usually done through some sort of compressor. And then that air is at a higher pressure, and that air can then do useful work. Okay, so that's energy. Now, energy, which also is referred to as power, this is really the capacity to do work. And we say that because then the units for energy are joules per second. And really, the units here, I'm sort of pausing here because I think I may be sort of interchanging terms, but hopefully you can just get a sense of the bigger picture. Really, power is really energy per time. Okay, so again, really these two concepts here, all right, those are related, and then your power, okay, is how much you can do per time. So these are still energy forms, okay, but when we're talking about how quickly you can do something, that's power, all right? So I start sort of in the middle here, all right, the types of energy that you might be used to in everyday life. We step up a level to say how quickly can you expend that energy, and that's time, and that is measured in watts or horsepowers, okay? Now, let's then jump to some physics. So we talked about power, we talked about energy / work. All right, how do we do that work? So we talked about here, if we lift up a block that has some weight and you raise it up a height, then it has potential energy. And if you let it go, then it's going to drop back down. And again, I'm just throwing some formulas here at you, but just take my word for it. Then whatever potential energy you had, then it's going to change into kinetic energy, and then you could solve for the velocity. Anyways, the point I want to get at here is you're doing work by lifting it up, okay? You have some amount of joules, and so let me delete this here, okay? And you can get it to change from potential to kinetic. Now, if we think just about work, all right, work is some force applied across a distance. So again, if you have this block and you apply a force, if the block moves over some sort of distance, okay, then you will have done some work. So force is measured in newtons, distance in meter, and that is, Newton meter is a joule. And this force is applied across some distance. So we're going to have another episode on simple machines, but the wedge is actually a good example of that. So you say you have a block here, and you could lift it up some height h. All right, but let's say it's really heavy and it's easier for you to push. So you could push it across some distance d. All right, and that's the work that's going to be involved. Okay, so lastly, again, we're just trying to get a sense of concepts here. And if it's all confusing to you, don't worry. It makes more sense as you see this more and actually do it in action, see it in real life. Then lastly, we have a force. All right, a force is something that causes something else to move. So you can say that there's a gravitational force. If we have a stick here, if we apply a force to it, then let's say this is a top-down view. In real life, this stick here, there's actually a frictional force that's opposing it. All right, and we encounter this if you just try to push something across the room. But when this force, this capital F force, as it goes from 0 to some amount, all right, then you're able to push it. Okay, I think that's where we'll pause. I know there's a lot of information, but what I want you to take away is energy. Okay, all different ways to store energy. If you go up a level, that energy can be expended or used at a certain rate per time. So that's why it's joules per second. Okay, and then in terms of how do you get energy, right? You do work. So again, you lift up an object a certain height. All right, you moved it across a certain distance. You moved it up an inclined plane. That's how you go from the force that you expended, all right, across a distance. That gets you work, that stores energy, and then how quickly that energy can be used, that is power. Okay, I'll pause there. Thanks for listening.